Xiaomi just built a mini AI computer that can run a 120 billion parameter model locally. It is called the Xiaomi AI Cube. It uses two new Xiaomi-designed AI chips. It runs a large 120B model together with a much faster 3B model and operates at up to 150 watts under sustained load. One of those chips supports as much as 160 gigabytes of unified memory. Xiaomi says that is enough to deploy models with more than 200 billion parameters on a single chip. On paper, that puts this small prototype in the same conversation as the NVIDIA DGX Spark and High Memory Max Studio. But there is a catch. Xiaomi has not revealed the price, the software, or the 120B model's actual speed. The AI Cube is still an engineering prototype, and we do not know whether it will ever become a product you can buy. So, in this video, we'll look inside the AI Cube and explain the new O100 and D100 chips. We'll separate the impressive numbers from the missing details, and find out whether Xiaomi may have created a serious new local AI machine. The AI Cube is not powered by one enormous processor. Xiaomi divided the work between specialized chips. The O100 is a dedicated AI accelerator. Its job is to move model data quickly and generate tokens without being held back by slow memory. The D100 provides large unified memory and additional AI compute. It was originally designed for the demanding models used in intelligent driving systems, but Xiaomi is also using it as the foundation of a local AI computer. A separate system processor handles the normal work of running the machine. Together, these chips allow the Cube to keep two models ready at the same time, a small 3B model for fast, simple requests, and a much larger 120B model for difficult coding or reasoning tasks. Xiaomi calls this a fast and slow system. Instead of waking up the largest model for every question, the Cube can use the small model when speed matters. It moves to the large one when the task needs more intelligence. That is an interesting design, but to understand why Xiaomi needs multiple chips, we first need to look at the problem the O100 was built to solve. Running a large language model is not only about raw compute. For every token the model generates, enormous amounts of weight data have to move through memory. If the processor is ready, but the memory cannot deliver that data quickly enough, the compute cores sit waiting. This is one of the biggest limits on local LLM speed. It is often called the memory wall. Xiaomi's O100 attacks that problem by changing where the memory sits. Instead of placing memory beside the processor and connecting it through a normal interface, Xiaomi stacks it directly above the AI compute layer. The O100 uses a 6nm logic chip with three-dimensional wafer-level stacking. Xiaomi says nearly 29,000 connections run between its layers, close to 300 times more than a standard LPDDR6 interface. That gives the chip up to 1.22 terabytes per second of near-memory bandwidth. For comparison, Apple's M3 Ultra reaches 819 gigabytes per second. But this does not automatically make the O100 faster than an M3 Ultra. The architectures and software are completely different, and bandwidth alone cannot tell us the final token speed. Still, 1.22 terabytes per second is a serious number for a compact local AI system. The O100 contains 14 AI compute cores connected through Xiaomi's own high-bandwidth bus. It can even change how data moves between those cores depending on the workload, one pattern for processing the prompt and another for generating the response. In Xiaomi's demonstration, the chip produced up to 330 tokens per second with a 3B MiMo model. That is extremely fast, but the model size matters. This was a small 3B model, not the 120B model shown inside the AI Cube. Xiaomi did not reveal how quickly the larger model runs, so the O100 appears to solve the speed side of the problem. The next chip tackles capacity. The D100 is a 3nm chip with a 20-core CPU, a 16-core NPU, and support for up to 160 gigabytes of unified memory. It was designed primarily for Xiaomi's future intelligent driving systems, where large models need to process cameras, maps, navigation, and driving decisions locally. But those same features also make it useful for large language models. Xiaomi says, a single D100 can deploy models with more than 200 billion parameters. Multiple chips can also be connected to Xiaomi's high-speed interconnect for even larger workloads. But what does supporting a 200B model actually mean? A 200B model at 4-bit quantization needs roughly 100 gigabytes just to store its weights. Context, KV cache, and the inference software need additional memory, but the complete model can fit inside a 160 gigabyte system. At 8-bit precision, the weights alone would need around 200 gigabytes. That would already be too large for one chip. So Xiaomi's claim is believable under the right quantization, but fitting a model into memory is not the same as running it quickly. Xiaomi has not published the D100's memory bandwidth, AI performance, power use, or token speed. It also did not say which 200B model was tested, at what precision, or with how much context. The chip has completed development and validation, and Xiaomi plans to use it commercially in 2027. Until then, the most useful evidence is the working AI Cube prototype. At Xiaomi's event, the AI Cube was shown running both a 120B model and a 3B model locally. The company presented it as a machine for tasks such as local coding and game development. The system can send simple work to the fast model, then move harder problems to the larger one. This could be useful for agentic workloads. A small model could handle routing, simple tool calls, or quick edits, while the 120B model focuses on the steps that require stronger reasoning. The entire machine operates at up to 150 watts under sustained load. That is one of the most interesting parts of the announcement. Xiaomi is not showing a server rack or a multi-GPU workstation. It is showing a compact prototype designed around local inference. But we still need to be careful. Xiaomi has not identified the 120B model. We do not know its quantization, context length, quality, or tokens per second. The company also has not announced the Cube's exact memory configuration, operating system, ports, supported model formats, inference frameworks, price, or release date. And software support may decide whether this machine matters at all. NVIDIA has CUDA, Apple has Metal, MLX, Llama.cpp, and a large community already optimizing local models. Xiaomi will need stable drivers, optimized kernels, quantization tools, and support for popular inference software. Great hardware without a usable software ecosystem can remain an impressive demo that few developers can actually use. If Xiaomi turns the Cube into a real product, which model would you want us to test first? Let me know in the comments. So, how does Xiaomi's prototype compare with the local AI machines already available? NVIDIA's DGX Spark has 128 gigabytes of unified memory and officially supports inference with models up to 200 billion parameters. It also offers NVIDIA's mature AI software stack and costs several $1,000s. Apple's M3 Ultramax Studio can be configured with up to 512 gigabytes of unified memory and provides 819 gigabytes per second of memory bandwidth. It can load much larger models, but high memory configurations are extremely expensive. Xiaomi's Cube combines support for up to 160 gigabytes of memory with an accelerator reaching 1.22 terabytes per second of near memory bandwidth. And it demonstrates a 120B model inside a system drawing up to 150 watts. Those numbers look competitive, but they do not yet make the Cube faster or better. DGX Spark and Max Studio are finished products. We know their prices, software, real-world speeds, and limitations. For Xiaomi, nearly all of those details remain unknown. Price could change everything. If Xiaomi sells this as an affordable local AI computer, it could put far more pressure on NVIDIA and Apple than another expensive workstation would. But if the Cube never leaves the lab, its impressive specifications will not matter to local AI users. Subscribe if you want to see the real performance comparison when Xiaomi reveals more details, or if the AI Cube finally reaches the market. The Xiaomi AI Cube is one of the most interesting local AI prototypes we have seen this year. The O100 attacks the memory bottleneck with 1.22 terabytes per second of near memory bandwidth. The D100 adds enough unified memory to make 120B models practical and 200B models possible under the right quantization. Put them together, and Xiaomi gets a compact 150-watt machine. It can keep a fast 3B model and a much stronger 120B model running locally. The concept is real, the chips have been built, and the prototype was shown working. But the final verdict has to wait. We need the price, we need the software, and most importantly, we need to know how fast that 120B model actually runs. Until then, this is not a DGX Spark killer. It is proof that Xiaomi is preparing to enter the same market, and it may have a very different approach when it arrives.